Hello and welcome to this installment of Ms. Russo's 6th grade life science. Today we're going to be talking about the evidences for evolution. So first, let's talk about what is evolution. Well, evolution is a gradual change in a species over time. Evolution explains the diversity of life today as well as in the past. And the scientific theory of evolution explains how living things descended from earlier organisms. And essentially, evolution is the key to understanding the history of Earth. One thing to note about the scientific theory of evolution is the definition of a scientific theory. We've talked about this in previous units, so I want to remind you all that scientific theories are well accepted explanations of the natural world based on data from observations. So what evidence supports evolution? We said that scientific theory of evolution is based on evidence. Well, what evidence is there to support this theory of evolution? And there are 4 types of evidence to support the theory of evolution. And the first is fossil evidence, and then genes or comparative genetics, homologous structures or comparative anatomy, and early development or comparative embryology. We'll take each of these 4 types of evidence in the upcoming slides. So first, let's look at fossil evidence. Fossils are basically preserved specimens or imprints in rocks of ancient organisms. So fossils of ancient organisms can provide clues about how and when new species evolved and how organisms are related. For example, scientists have found fossils of whale-like creatures that had legs, and based on this fossil evidence, this suggests that whale ancestors once walked on land, and here we see one of these whale fossils. This is an intact skeleton hanging in a museum somewhere in the world. You know, sometimes scientists see or another example would be scientists sometimes have 2 different fossil specimens from 2 seemingly unrelated organisms, but then they find a fossil that predates them, dates back thousands and thousands and thousands of years prior to those 2 fossils, and that fossil can be kind of a bridge between the 2. And then they can say that if they find evidence like this, then they can determine that that older fossil might actually be a common ancestor of these 2 fossils. And the next evidence is genes or comparative genetics. And this is an actual field of study in science. And through this evidence from DNA and protein structure are used to see how organisms are related and then used for comparison. You'll remember from our unit on DNA and genetics that DNA is composed of or made of sequences of base pairs. And in different organisms, these base pairs occur in a very specific sequence. And scientists or geneticists can compare these sequences in one organism to another to determine how closely related they are. If they're closely related, they will have a majority of the base pairs being identical. And the third evidence for evolution is homologous structures. And this falls under the field of comparative anatomy. And yes, this is an actual field of study. In fact, when I was in college, I took a course in comparative anatomy. And comparative anatomy looks at homologous structures. Homologous means similar or same. And homologous structures are similar structures that related species have inherited from a common ancestor. If you look at this picture, we see a limb of a human, a cat, a whale, and a bat. And their outward appearance is very different. You would never mistake a human arm for the wing of a bat. They look completely different. But when you look at the anatomy of those limbs, you find that they are extremely similar. In fact, their skeletons have exactly the same bones. The bones may have a slightly different shape and size, but they have the same bones. You can see highlighted in orange is the radius, and this is a bone in the human forearm, but it's also located in the cat, in its leg. If you look at its leg, you can see that bone highlighted in orange. And in the whale, you also see a radius highlighted in orange. In the bat, you see a radius highlighted in orange. So the fact that they have similar skeletal structures, those are homologous structures that suggest they came from a common ancestor. And then finally, we want to talk about early development. And this falls under the field of comparative embryology. An embryo is, once an egg is fertilized, it becomes a single cell that starts dividing, and it develops into an embryo. And so this is the stage of development of an organism before it's born. So when we look at embryos in early development, ancestors can be compared to new organisms to determine how closely they're related. Now, if we look at this picture, we can see that starting from left to right, we've got a fish, a salamander, a tortoise, a chick, a hog, a cat, a rabbit, and a human. And on the bottom, this is a later stage of embryologic development. But even then, so these are not born yet, but even then you can see that they look very different. They are distinct, they look like distinctly different species. But if you look up at the top to that first stage of embryologic development, that very earliest stage of development, they're almost indistinguishable. You cannot tell one species from another. They have very similar structures in very identical locations. And this suggests that they come from a common ancestor, that they are related in some way. In fact, if you take an organism and you study its embryology from the time that the egg is fertilized into a single cell and watch it go through each stage of embryologic development, it is almost as if you are witnessing evolution. It's quite fascinating. Okay, so these evidence, sum total, the take-home point here is that these 4 evidences provide proof that organisms have changed over time. Remember, that change over time is evolution. So here's a little evolution humor for us to end the presentation. So stop following me. I think we all recognize this evolution picture. And this is a little joke on it. And sadly, the evolution of the species comes to an abrupt stop during the digital age, as we all walk around looking on our phones. And one last little funny picture. We all recognize Sid the Sloth from Ice Age. Well, thanks for watching, guys, and happy studying to you all.